In this video, we will look at the Model Context Protocol, MCP, which is a standardized approach to managing context in AI applications. We will cover its importance, its core features, architecture, and some practical use cases. If you have read 20 pages, watched 40 videos, and still confused what Model Context Protocol is, I'm sure after watching this video, things will be more clear to you. Okay, so MCP is an open standard developed by Anthropic, the company behind very famous GPT, which is Claude. While it may sound technical, but the core idea is quite simple. Give AI applications a consistent way to connect with tools, services, and data, no matter where they live or how they are built. So before we go ahead and try to understand what MCP protocol is, let's first try to understand a problem statement. Let's try to understand why do you actually need MCP protocol at first place. Okay, let's just try to simplify the problem. Let's say you have AI assistant such as Claude, okay? It needs to access some data, okay? Customer database. Why do I say AI assistant Claude needs to access the customer database? What it has to do with the real-time data? So as we know, AI assistants, behind those AI assistants is running LLM, okay, which is a large language model. Large language model by nature is static data, okay, a data which has been, collected, trained. It understand a few things, okay, which had happened at the time of training, but it's not able to answer real-time questions. You cannot ask an LLM that tell me the weather for London this afternoon, for example, or you can't ask about the stock price because stock price is happening right now, weather is happening right now, okay? So LLM is not capable, or it's not created to answer those future or real-time questions, okay? It's kind of set in some time because whenever the model was trained. So in order to fill this gap, people try to feed real data into AI applications, AI agents, and then try to feed that data into LLM. So everybody came up with their own ideas. They started kind of doing things. So let's take this example. My AI assistant Claude needs to talk to customer database, okay? So what do I do? In order to support or supply this data, I will build some sort of integration over here, okay? Then my AI assistant can talk to this this little integration, whatever that integration system is. Then this integration system will be able to talk to customer database, and then it will be able to translate and give answer back to my AI assistant, which is Claude in this example. Let's say tomorrow you want to connect another AI application, ChatGPT in this instance. What do I have to do? I have to repeat the same process again, okay? I have to build another integration over here. And then I connect, and then ChatGPT will be able to talk to this customer database. Now let's say, hypothetically, I have to now connect another service to my AI applications. Let's say I have to give some sort of news information, some weather data, etc. What do I have to do? Again, yes, you got it. I have to build another integration, connect these pipes, boom, my data is now reaching to these AI assistants. Tomorrow, hypothetically, let's say there is another assistant coming, maybe Gemini or maybe Copilot or I don't know, Apple's Intelligence or whatever, okay? And I have another data set, some sort of, local data, okay? The file systems, PDF reports, whatever. What do I have to do again? You got it right. I have to build another pipe, another integration, create these pipes, and then I'll be able to supply, answer or data back to my AI assistants, my AI application. But let's try to understand what's wrong with this approach. The biggest problem with this approach is I have to maintain, n number of code repositories which will be representing each AI assistant. Okay, in this instance, just to support 3 AI assistants to my customer database, I had to create 3 code repositories, for example. Okay. Yes, you can argue I can have a one code repository, blah, blah, blah. That's not the point over here. The point is I have to maintain separate logic, separate workflows for these different clients. If something changes tomorrow, whether it's in my database or in AI assistant, I have to change these things as well. Okay, I have to change these things. So maintenance is very troublesome. It's not easy. Okay, as you can see over here. So how do we solve this problem? So in order to solve this problem, Anthropic in November 2004 or December 2004, they came up with an idea saying, okay, why don't we have some sort of protocol which we can introduce between these various applications and my data sets, which can seamlessly talk to each other. Okay, so I don't have to maintain these data points per client or per AI application, because AI applications are growing day by day. So this is where Anthropic came, they published paper, everybody liked it, and now MCP has been established. It has become kind of open standard to communicate between AI applications, LLMs, and your personal data set. Okay, personal data set or real-time information. So how does MCP actually works, or how does it try to fix the problem? Let's just step ahead and just try to understand it. So here we go, our MCP protocol. So very first thing in the MCP protocol is something called MCP server. I'll try to explain what MCP server is little later, but let's say the idea is to put a server in front of your data source. In this example, I have a customer database, so I can put database MCP server. Same goes for my file system, same goes for my some sort of web service or whatever, right? Now, my integration has become super easy. So instead of my AI assistant directly talking to my database or one very specifically created connection point, I am actually now able to connect using MCP server. So I can have n number of AI assistants or AI applications over here, and they can reuse the MCP server which I have created for my particular service. Okay, so as you can just try to visualize it on the right over here, I can grow, or I can keep on adding as many AI applications, AI agents, AI assistants possible. I do not have to build new integration endpoint for that particular AI application. They all can talk using the standard protocol. That's the beauty of MCP protocol is. All right. So what is MCP? Let's just try to kind of have a little bit deeper understanding of MCP protocol. It's a standardized protocol. It provides a standardized way to share and manage context between different AI applications for consistent communication, as we just learned. Interoperability. Okay, MCP enables seamless interoperability, allowing diverse AI applications to work together effectively without compatibility issues, as we saw earlier in the diagram. Okay, enhanced AI experience. By managing shared context, MCP enriches AI interactions, leading to more intelligent and context-aware experiences. Okay, now your AI applications not only can work on that static data which they were trained on, now they can, they are more context aware in the sense like they are more aware of the current situation. Okay, because you are feeding that context through MCP protocol. Okay, as we go ahead, let's just try to understand some MCP concepts. Very first thing we need to understand, okay, how my AI assistant will be connecting to my data source. So as you can see over here, I have my data source, and the whole objective is to make this data source available so all the AI applications, AI agent can connect to it, they can talk to it, they can retrieve information in more standard, more open way. All right. So the very first thing, first term you will be hearing again and again is called MCP host. What is MCP host? So MCP host in MCP protocol is the AI application. What we saw earlier, Claude, like ChatGPT, Copilot, or Gemini, or your own client, for example, which is talking to various LLMs, etc. So just remember this: MCP host is equal to your AI application, right? Second term which we need to understand is called MCP client. MCP client is a component, okay, which sits over here within your AI application. So it's a component that maintains a connection to an MCP server, and then it obtains context from an MCP server for the MCP host to use. Okay, what about MCP server? Where it is? There it is, my MCP server. So MCP server, basically it's a program that provide context to MCP clients. Let's just finish that picture. So as you can see over here, this top bit in this greenish color, or whatever that color is, this is my MCP host. Right within sitting a component called MCP client. Then I have my data source, and then I am building this thing called MCP server. So MCP server, you can say, is an abstraction layer sitting on top of your data source, which MCP client will be talking to. Your logic will be sitting here, behind the MCP server. You're kind of hiding or abstracting your business logic. MCP client and server can talk using the MCP protocol at this point. All right, let's just move on. So we saw, or we talked about participants in MCP protocol. Let's talk about layers in MCP protocol. Okay, so you have your MCP client and you have MCP server. Very first thing we need to understand is called transport layer. Okay, how MCP client will be talking to server. Important thing to remember over here is entire MCP protocol is based on client server interaction. You must be very familiar with client server interaction, because you must be building the enterprise web applications, for example, where you have a client, maybe browser, or your application is sitting on the server and the client is making a request. You are processing that request, replying back. Same concept is applied on MCP protocol. Okay, it's just client server interaction, and everything is kind of sitting behind that, and these two things are abstracting those bits and bobs for you. So transport layer, here is the transport layer. So transport layer is made up of standard IOs and streamable HTTP. It defines the communication mechanism and channels that enable data exchange between clients and servers, including transport specific connection establishment, message framing, and authorization. So all the security bits will be basically sitting here, how handshake should happen, whether it's on TLS or MTLS or whatever. Now, second thing which we need to understand is the data layer. So conceptually, the data layer is the inner layer, while the transport layer is the outer layer. Okay, so transport is maybe TCP IP level, or on top of that HTTP level or standard IO level, and then inside that you have something called data layer. Okay, let's just try to understand what data layer is basically. So it actually defines the JSON RPC 2.0 based protocol for client server communication, including lifecycle management and core primitive such as tools, resources, prompts, and notification. The very, very important thing over here for us developers is a thing I call primitive. Okay, we'll have another slide to cover that thing. Let's just try to understand what's really going on over here. So I had my client, I had my server. This is my transportation layer, HTTP or standard IO or whatever that is, and on top of that, on that layer is traveling my data, which is basically using RPC JSON. Okay, JSON RPC 2.0. Okay, so all the communication has been kind of defined using JSON RPC 2.0. If you don't know that, please go and read and try to understand what JSON RPC is. Okay, so it's basically, as you can see, RPC means remote procedure call. So you're trying to invoke a method at the server side by giving the method name, the input parameters, and whatever else is required by your remote method. Standard if we just spend maybe a few more seconds on standard IO. So standard IO transport, it basically uses standard input output stream for direct process communication between local processes on the same machine, providing optimal performance with no network overhead. Yeah, so you have a cloud desktop or ChatGPT desktop running, and you can have the MCP server running in your own local machine. It doesn't always has to be on the server side. So you can use standard IO protocol to communicate with your MCP server. So the communication will be super quick, because you don't have to do a lot of handshake, a lot of security thing which you can bypass, because everything is running in your local machine. So this protocol is preferred when your server and your client both are in your local machine. All right. Streamable HTTP, on the other hand, it uses HTTP post for client to server messages with optional servers sent events for streaming capabilities. Right. All right. So as I said, the most important thing for us developers is core primitives. So MCP primitives are the most important concept within MCP. They define what clients and server can offer each other. Okay. These primitives specify the type of contextual information that can be shared with AI application and the range of actions that can be performed. The very first thing which comes when we talk about core primitives, and you may have heard this term, at least me talking in other videos, etc., is called MCP tools. So what is MCP tool? They are executable functions. Okay, API calls, for example. Okay, some sort of database records. When you want to fetch something from the database, or you want to make API calls, you can publish them as MCP tools. Okay, so your client then will be able to execute those tools to have some sort of side effect at server. So when I say side effect, means grabbing some data, or you want to maybe update some database records. Just remember, tools can have side effect on the server side. That is the most important thing to remember. Second is resources. So resources can be seen as read-only information which you would like to access in your AI assistant or your AI application to have more context. For example, you want to read something from a file. You don't want to change the file. If you want to change the file, then obviously you will be building tools. But if you just want to have, a capability of reading some stuff, you would be using resources primitive. Okay, file content. Maybe, you have a database feed. You have extracted something. You want to grab that information and show in your AI application, or want to perform some non-side effecty type of logic. You would be using resources over here, some sort of just API responses. Okay, you made a call, you have a static data, it's just giving you the API response back. Okay, so that primitive is called resources. You can publish resources as part of your MCP server offering, I should say. Third primitive is called prompts. What is prompts? These are basically reusable templates. Okay, we all know prompts these days, because when you're interacting with ChatGPT or Cloud Desktop or any other AI assistant, you give some information. You give a prompt. You say, okay, this is my requirement. Please, you fulfill that. Okay, so that's called prompts. Let's just try to kind of have a little bit more understanding. Okay, where tools fit, what the capabilities of tools are. Okay, some real world examples as well. So building block tool. Okay, what is the purpose? It's for AI actions. As I said earlier, it can have a side effect on the server. Who controls it? Model controls it. Okay, examples can be search weather data. Okay, send some sort of messages, create events. So all these things, as you can see, has potential of side effects at the server side. Resources, they are purely for contextual data. It's controlled by the application. Okay, documents, calendars, emails, weather data as well. You're just getting a feed of data but not doing anything. Prompts for interaction templates. Okay, it's user controlled. Example could be like, okay, plan a holiday. Okay, so you're getting some data, but you have a predefined prompts. You can predefined prompt template. You grab some data and then fill into that template, and then MCP server can return, which you can pass it on to LLM, and LLM can take action on it, like summarize my meetings, draft an email, blah blah blah. Okay, so that's it. I hope you now have a full understanding of what model context protocol is, and where MCP server sits, where MCP client sits, and how your AI application is making use of those things. All right. I hope you liked the video. Thanks for watching. Thanks for your time. I'll see you in the next video. Bye for now.